First thing we need to do, our HO and our HA. They said what?
The mean of one is not equal to the mean of two.
So
That's the claim that they.
they're claiming that they're not the same, right?
Yeah.
So that's the HA, so mu1 does not equal mu2,
Yeah.
claim. What's our HO then?
Mu1 is equal to
mu1 equals mu2. Everybody understand that much? That's the first thing you're gonna have to do on the test, getting 3 points there. Next thing, we're gonna draw our curve, left-tailed, right-tailed, or two-tailed. Draw that. Give you a point if you knew it was two-tailed. Then another point for getting the correct things. I don't have my chart up here. Alpha was what? 10? Yeah, 0.10. So looking on your chart, little bottom chart, what is it?
1.645.
Which one is it? I heard two there, 1.645?
Yeah. 96. It's two-tailed.
Yeah.
Two-tailed, 1.96?
No. No, 1.6.
Yeah, 1.65.
Gosh.
So negative 1.645, is that right?
Yeah.
And then a positive 1.645?
Yep.
Everybody agree with that?
Yep. Yes.
Then we gotta find the test statistic that we're looking at. Do you guys wanna use your calculators? Is that the way we wanna go?
Yeah. Yes.
Alright, you don't? You wanna do it out longhand? Somebody tell me the formula. Well, the rest of you can do it using your calculators. That's fine.
X bar 1.
What is X bar 1? Help me out. It's got the chart there.
42.
Minus,
45.
and then we know the rest of it's 0, right? So I'm not even gonna write that down. And then on bottom,
The square root of 4.7. Oh. Square root and then 4.7 over 35. Or well, 4.7 squared. And then plus 45 squared.
4.5
4.3.
squared
Yeah.
over,
35.
they did 35 on both tires.
Yeah. Yeah.
So on top here, I know I got -3. On bottom, do what? Yes.
Can I speak with Michael Davis for a moment?
Yes.
Student speak.
Somebody type all this into your calculator for me.
I think she was on the phone.
Oh.
What am I going to anyway? I'm counting.
You sure those staples didn't go all the way in?
Alright.
What was that laugh? So the n is the number of like trials.
Right,
Okay.
for each one.
That makes sense.
Anybody get the bottom part yet?
1.56.
And then divide that, -3 divided by 1.56.
Negative 2.59.
Is that what, those of you who use your calculators, is that what you got, -2.59?
I got 2.7.
Yeah, I got 2.7.
Negative 2.7.
Yeah, negative.
But she didn't tell you that we're on a 2-hour delay?
Yeah, she's like,
So you're
we're on a
not-
2-hour delay, but it's just 2 hours of intervention, so you've gotta be here. Okay? That was the plan.
-2.79, is that what we're going with?
Under cosmetic testing.
Now, once you have that, we're gonna check it. Does it fall in the shaded or outside the shaded?
And
So what's that tell us?
It's rejected.
Reject the null. Then to write it out, we're gonna say with 10% level, did you get it?
Yeah, I forgot to take the square root of it.
Of significance. Then you use your chart. There is, the claim was the HA. We rejected the null.
Next thing.
So what's the rest of our there is gonna say?
Enough evidence to support the claim.
Enough evidence to support, let's listen right here.
Hey, look at my homework, I wrote it all out.
The claim that, what was the claim?
One is
92.
Right, that's not what Sean's gonna write. That the breaking differences of
Mean breaking distance is
the tires are not equal. There, Sean, I'll let you put equal like that.
I wrote it out.
You wrote equal out all the way? You ain't gonna give me a chance to take off any more points.
We did 32.
32. Sociologist thinks that the middle school boys spent less time studying in 1981 than the middle school boys do today. A study was conducted in 1981 to find the time of middle school boys spent studying on weekdays. The results are shown. Results for a similar study for today shown in the other ones. At a 3% level of significance, can you support the sociologist's claim? Instead of me doing all this, let's just explain it, so because it's going to be a pain in the butt. What do you got to do with that first list?
Put it in there.
Put it in list 1. What do you got to do with the second list? Put it in list 2. Once you have each one of them in list 1 and list 2, let me erase all this. Once you have each one of them in list 1 and list 2, you want these things. Because those are the 3 things that we need to plug into our calculator, right?
You put,
Oops, my fault. You need a 1 there, you need a 1 there, you need a 1 there. Because then we also, for list 2, we want,
yes.
we want that. Oops, 2. Does that make sense? Once you put all that in there, that's going to tell you what your Z is. Now, the other thing that might be hard on this one is for your HO and HA, what was the claim this time? Study is
Spent less time in 1980.
so less time. So our HO and our HA.
HO is equal to or greater than, like mu1 is equal to or greater
Is that our claim?
than. No. Our claim is we use less than
So that's our claim this time. Left-tailed, right-tailed, or two-tailed?
2.
Now, the other part that makes this one a little more difficult, and I thought I took all these out, but apparently I forgot this one, says it's 3%. Is that on our little chart? No, so now what we have to do is we have to go to the big chart and just try to find, so on the big chart,
Find the closest 2 points.
find the closest thing in the middle here to 0.03, and then match up the 2 things. Anybody find that for us?
Negative 1.88.
Everybody agree with that?
Yes.
Right. Again, I'm trying to get rid of those for you so that we can just use the little chart, but every now and then I forget. So that, got 0 there. Figure out what Z is on your calculator, check it. I just don't feel like punching all these into the list. Is that all right, Ron? You won't be upset with me, will you? I promise you that the quiz, you don't have to punch them all into a list. Other questions?
Let's start this quiz.
You ready?
Yep. Sure, man.
Can use your notes, can use your books, can you, whatever, just can't use your neighbors. On the quiz, please make sure you try to write legibly, and you're going to do the entire thing. Does everybody understand that? So you're doing the whole problem, doing HOHA all the way down through interpreting.
At least I'm-
Is wide.
Why does your tray look different?
Because before I didn't have those trays and it said, put it on the metal table. And I took a picture, put it on the paper. And now I can't change the wording on it, so I had to post something on top of it. No, it's really because I wanted the tray! Put it in the tray! I was yelling at that.
See, a couple people yelling.
Lily. Yeah, Lily did
I'm
one.
off my meds today. I forgot to.
She was gonna do it for you, Brendan, you should've.
I'm so sorry.
You're more than welcome. You'll probably get most of it. Turn in a quiz on metal tray.
I should say in metal tray too, I didn't feel like posting something stuff.
Okay.
Shouldn't take you more than a few minutes. We're not taking the whole time to do this. Don't just sit here and do nothing. At least get some of the points. Sean, this time I might take off for a terrible bell curve drawing.
I'm leaning towards them.
When we get to the review of this chapter, Sean, like the day before, something remind me, and we'll go through so I can write down what to do to find the Z on that first part, and I'll add it to the review notes on the calculator. Yeah. So you're doing everything up till the interpretation, you really don't have to do any decision. Then, if you look at the answers in the back of the book or something about it, might be in the back of the book, it would do like half of the interpretation. You get them the whole problem. The hardest part that I have on these, Wade, is
Tell them the difference.
the HO and the HA. That's figured out, okay, I gotta read it like 5 times to say, okay, what are they saying?
Like, it's more of just a one point thing.
So, yeah, so that's why, for you, that's why most of them, we just go all the way and find it, no problem. Shaded part easy. You don't wanna do just the thing to it, this is the hard stuff.
No, I care more about the fact that I just used the last page in my video.
That's all right.
In a real life situation, I have
So I wonder if I could.
Mr. Ebersole.
How would you find the level of significance in a real life situation?
You have to, the level of significance, you set up yourself. You say, okay, how precise do I wanna be here? So it could be, if it's something with your level of significance, let's say you got a 2 ticket. If you do like a 1%, then you got real small rejection regions out here. If you do like a 10%, you got bigger rejection regions.
Okay.
So if it's something like the braking distances, we might wanna do a 10% because we don't want Gage out in the car that has a crappy brakes. Might not want to, the automobile manufacturer might want us to do 1%, because then it's gonna say, oh yeah, they're not lying to you. We might want to do bigger and even 10%. In the real world, it's usually like 25%. All right, if it falls in this 25%
I
range,
used the last page of my notes.
if it's like a life or death thing that could hurt somebody, we want the alpha to be big. So you actually make that up yourself.
Yep, and I was like,
Oh, no.
I looked at that and I did it like 3 different times. And then I was like, okay, I gotta look right here. Like, that don't look right.
I seen the little drawing, I seen the HO, HA.
I mean, I had an idea, but like,
Single
makes
word.
sense mathematically, you should be able to like,
Yeah, I feel like it's a 4%. Yeah.
How are you today, Miami?
Miami.
Not too bad, I guess.
Is that a Miami or Miami shirt? You got a lot of Miami.
Sim, is everyone done with the test?
Time to talk about it?
So,
Time to turn
flip,
it
flip,
around.
that's the final answer.
There was supposed to be a final answer.
Well, like, fail, rejected, or reject?
Oh, I reject.
You rejected?
Did you fail to reject?
You thought it was a brown day.
Yeah, I did too.
That makes sense.
What'd you get for the Z? 0.2?
Do you have the third block on it?
I did not get that.
I don't think so. It was.
Having during intervention.
Like 0.6.
Something like that.
Like,
I goes
0.2,
0.2.
that's what I got.
Yeah! I got your picture!
I was surprised because it said like 2.0 and I was like.
You say that was right. No.
Alright, what we're gonna cover today. I'll try to have those quizzes back to you next class. What we're gonna cover today. I just write the title down of this. Testing, difference between two means for small independent samples. Small independent samples. Last time we did large dependent. Now we're doing small independent. I know if I see you touch on, you're sitting right there. That's a good spot for you because now I can just grab it and set it on my desk.
How come you and Kenny stand by each other?
Yeah, we've never sat by each other. First quarter I was over there, he was over here.
Who picked the
Does that
numbers?
And I ain't made it out the first.
I didn't get to choose a number.
No, I did not before the numbers went.
Right, but who picked the numbers out of the bucket?
I never got to choose.
You're
a
right,
number.
you got 18 because that's the only one that was left.
She'll let me, I'll rate myself number 4.
Hey Phoenix, I heard nobody's sitting here, so. But I'm not in the booth because it's like the first week.
There is somebody sitting there. Zoe sits there.
Well, not right now.
I think Zoe would much rather sit here though. Than right there.
I'm pretty sure she'd rather sit up there.
Huge. I just moved that's
That
works for me.
All right, some of this. Pen to work, right? Some of this, same as last time. Samples got to be randomly selected. The samples must be independent. Each population must be have a normal distribution. So that's the same as last time. Nothing different about this. But if we're doing small samples, instead of using z-scores, what are we using? T-scores. All right, so these use T-scores. You might want to at least write that down somewhere. That means we're going to have to use a different chart. We're not going to use the front page anymore. We're using the other page. It's the T chart. So on the back of that, go back one more. I think it's right there, isn't it? Yep. It's like chart number 5 or something. Is that what it is?
Yeah.
Table 5. Now, again, the bad thing with these small samples, there's going to be 2 different ways that you could go. And you've got to make that decision when you start the problem. All right? And that's what the next couple of slides are going to explain to you. When we get to those next slides, I'm going to probably tell you, don't write this down. On the next slide, there's something that's easier to write down, write it down, and so on and so on. So I've added several things, trying to make it as easy as possible, rather than harder than it has to be. So this one, the test statistic, go ahead and write this down. This is the T that we're looking for. Again, on here, I went through and found how you can do it on your calculator, and I'm going to tell you how to do that. But this is what you're finding. Each time you're finding that right there. So it's so far we haven't separated it off yet. What's going to separate is that bottom part, that standard error, is going to be different for one situation than it is for another situation. And that's where the 2 things are going to be, where they're going to differ at when we get to that. Again, what do we know about mu1 minus mu2? It's always going to be 0. So that part of the equation, not sure why. I know there's probably a reason. I don't remember it now from 30 years ago when I actually took this course in college, what that reason was. know that we're not gonna get to the reason regardless of what it was. But there, I'm sure there's some reason that it's there. Oh, I do know the reason. I don't remember it. Sometimes, we're assuming every single time that what's true about mu1 and mu2. That when you subtract them, they equal 0. So they're what to each other? They're equal. We're assuming that they're the same. Later on in this, in prop stats, you would do stuff where mu1 and mu2 are, you're not assuming that they're the same. That's where that second part of that top would have to be used. We're not going to get to that. So that's the T that you check once you draw your little curve, and we got our rejection region is right here, and we check to see if T falls in it or outside of it to decide whether to reject or fail to reject the null. Don't do that. Be able to get that back up again. The standard error and the degrees of freedom of the sampling. Remember, degrees of freedom. How do you find the degrees of freedom?
N-1.
Just n-1. That's nothing hard about that. It's actually going to be a little different for these because we have 2 n's. So that's part of what's going to be different. This is where it gets different. Hold on a second before you start writing anything down. Write this down. If variances are equal. So when you start the problem, there's going to be 2 different ways that the problem could go. The variances of the 2 samples could be equal. The variances of the 2 samples could be different. So we're going to have to decide. And they're usually they're going to tell you. I shouldn't say you have to decide. In the problems that we do, they're going to tell you. Assume that the variances are equal. Assume that the variances are different. And what changes there is your standard error. How you find your standard error and how you find your DF change if the variances are equal or if they're not equal. So if the variances are equal, this I do want you to write down. If the variances are equal, your DF, you do that to find it.
So just the DF, that's all you want to
For now, yeah, because I got the formula on the next slide. And I'm also going to write this in here. Write that with if the variances are equal. If the variances are equal, what we do is we take everything from sample 1, everything from sample 2, and we put them all in a big pool. Right? So if the variances are the same, it's called a pooled sample. So we just take everything from both samples and put them together. On your calculators, when I show you how to do this, how to find your T's on the calculator, you're going to need to know this because it's going to ask you, is it pooled or is it not pooled? So if the variances are equal, then it's a pooled sample. We're taking everything from one, everything from the other, just like down here in the DF, everything from one, everything from the other, adding them together, and then instead of subtracting 1, we're subtracting off 2.
Same thing. You find the DF is a correct too.
Right. So it's the same. It's basically the same thing as we've always been doing.
You find the DF for both.
Right. So what Wade's saying is, hey, we could have found the DF for sample 1, DF for sample 2, and then we just add those together to get the overall DF. This is the formula.
Oh. There's a way to do that on calculator?
Yes.
Yeah. That sounds good.
Benjamin, you want to do this one?
Again, what do we know about this first part of the formula here? That's 0 there, second part, whatever, second part of the top. That part's gonna end up being 0 every time. Formula looks really hard. It's not quite as hard because you're gonna know all the numbers, you're just plugging in stuff. Stuff like N1 minus 1, that's just the degrees of freedom. So you could just stick that number in there. The S squared, that's your variance, you're just gonna stick that number in there. The bad thing with this formula is you sort of have to do it 3 parts. Do the top, do the first square root on the bottom, do the second square root on the bottom, then worry about the multiplication and then the division. So you have to go through and work it part by part. Now maybe Riley's smart enough that he can figure out how to plug all of that big whole thing with the 6 million different parentheses that he's gonna have into his calculator and get the right answer. Ebersole's not. I always miss a parenthesis somewhere. So I always have to do 3 separate parts, then worry about the doing the multiplication and the division. And 2, also remember the little 1s and 2s that are at the bottom of the letters. Even though mine look huge, I'm not sure why they look so huge. Those are just subscripts. They don't tell you anything other than sample 1 and sample 2. So they do absolutely nothing mathematical. And I don't know whether you'll have to, you won't have to worry about this, but if you were doing the stuff on your calculator, like if we were gonna do that problem that Brian wanted to do a little while ago, and we found this on our calculator, then when we plug back into this formula, you have to remember to do what to that? Square it, because the calculator tells you the standard deviation, we want the variance in there. You probably won't have to worry about that because of being able to just plug in the numbers on your calculator and deal with it that way. Everybody have that whole big formula down? Variances are not equal. Again, just write this part down at first. And I'm going to write this out here. Not pooled. And the other thing you can write down is to find your DF. You do that. If the variances are not equal. With your DF, when the variances are not equal, to find your degrees of freedom, you figure out which one's the smaller of the 2 samples, and you use that one. So whichever sample is smaller sample. So if we got one that's 10 and one that's 7, we use the 7 to find our DF. And you only need one DF, 1 degree of freedom. Now the bad thing with all of this is what we did the first section, a lot easier, not realistic out in the real world. It's not realistic that you're going to take, if we're doing the tire problem, not realistic that you're going to take 30 tires from this company and 30 tires from this company. It's a lot of money if you're doing that. So we're probably going to do like 6 tires from this company, 6 tires from this company. So we're going to have to use this way. If the variances are not equal, again, it's not pooled, and that's what the formula looks like. So I know Michael's hoping that all of them, we say that the variances are not equal to each other because that formula looks a whole lot easier than the other formula. Again, with this formula, mu1 minus mu2 and be 0 for everything that we're doing right now. Those are M's, Wade, those aren't U's.
All right, that's
I know, that's what I was saying.
So what was the point of the first equation?
Yeah, I was just about to ask that.
Standardized tests.
So this is for all of them, but your standard error is different. So what's on bottom is different for this, from this one to this one. So that's the formula for anything, but when you find your standard error, there's two different ways to find your standard error. So we probably didn't really need to write down that first formula, but that's, if you're doing small samples, that's the actual formula. So if you looked it up online or something, that's the formula they would give you. But they don't tell you that the standard error changes for whatever you're dealing with. This, I wouldn't write any of this down. Just telling you how you're gonna do this. Are both samples at least 30? If they're at least 30, what kind of test are we gonna use? Z-test. If they're not 30, then we look, are they both normally distributed? No, then you can't use the Z-test or the T-test. If they're not normally distributed, then we can't use either one, we just stop. You know there's probably like 7 of those on the homework, right, where you just say, oh, nope, doesn't work. None of those, Brian, I'm being sarcastic here. If they are, then both standard deviations known? If both standard deviations are known, then we can still use what? We can use the Z-test. If we don't know both standard deviations, or the population, or variances, then we have to use the T-test, and we have to go that route. Again, I think on the next test, I think I separated it so you'll know which one. I'm not trying to make this too completely difficult, but know that if you move on to a higher level, next person's probably not gonna be Ebersole, and they're not gonna be nice like me. They're gonna just give you these problems, and you're gonna have to decide, hey, where do I go to? On the calculator, to find your T, this is your test statistic. This is the number that you're finding using those big long formulas to see if it falls in the rejection region or not. It's not the critical value. The critical value here is T sub 0. You still have to use your chart to find that. But to just find T, our test statistic, we can do this on the calculator. Sure, it's different. Figure it out. No rivals. When you're doing this, to plug this into your calculator, again, the things you're going to have to know, the things it asks you for in your calculator, I think, again, it asks you for X bar, asks you for S, and this X bar 1, S1, asks you for N1, X bar 2, S2, and N2. I believe it asks you for all those things, right? And then it also asks you to decide which tail it is, whether it's left-tailed, right-tailed, or two-tailed. Remember, to decide the tail, you look at your HA to decide the tail. Then it asks you, is the variance pooled or not? If yes, if it's pooled, if the variances are equal. If the variances are equal, then you type in yes, or you highlight yes. If they're not equal, you highlight no. I think that's all it asks you, isn't it? And it says calculate. I didn't put that on there. If you wanted to put that on there, next thing you do, you get down and then hit calculate. And it'll show you the stuff. And again, once it pops up that other screen, all we really want off that other screen is what t equals. So as you're going through and doing these steps, again, first step, state your HO and HA. Second step, figure out what your alpha is, your level of significance. Third step, decide whether the variances are equal or not. They're going to tell you that. Fourth step, find your degrees of freedom. This is the one way to find the degrees of freedom. The other way is just n minus 1 for the smaller one. I have this on here twice, but I wouldn't write it twice. Number 4, to find your critical values, you're gonna, sorry, that should be number 4 here. 3 is all this. 4, you find your critical values, you're gonna use your T chart to find your critical values. Number 5, of course, is gonna go right along with this. You're gonna draw your little curve, figure out, which way you're shading and stuff, where your rejection region is, and find that critical value. So you're still, regardless of using your calculator, whatever, we're still going to have to find the degrees of freedom, and we're going to have to find the critical value, because the calculator doesn't tell us all that. All right? And we're still going to draw the chart and everything, just like we've been doing. Here you go, Gage. I'll tell you something. Don't leave this room. Your friend, the basketball player. You seen I had that no name up here? He can't. I swear I thought he was maybe going to be in tears because he didn't have. He had a 0 for a paper, and it's been hanging up there for like 3 weeks. And instead of looking at it like I said to do several times, he got another one and redid it that last day, last Friday, before into the 9 weeks. Today, comes in, happens to see it up there for the first time, realized it was his. I said, "Oh, really? That was yours?" I thought it was hilarious. I thought, you know what? You haven't been paying attention this whole time. Number 5, still on the same thing. You're drawing it. Number 6, finding your T. Again, find your T. You might be using your calculator if you don't like that big long formula. Number 7, decide whether to reject or fail to reject. And number 8, same as before, you interpret. Same as we've been doing for the last 2 chapters. I got on him the other day because he never talking constantly. And I said, you know what? Some of your peers have said that same thing about you, that you never shut up.
Sure.
Who was it? Was it Gage? He actually did. He picked you out right away.
He does talk a lot.
POD constant.
No.
On this,
Yeah, he does talk a lot too.
if the variances are not equal, same setup, the only difference is you find your DF different and you find the T value different. All right, the formula for this is different. I'm not gonna sit here and have you write all that down. It's same setup, just those two things. So you gotta know right away, variance is equal, variance is not equal. And they'll tell you that in the problem. Taking the braking distances of 8 Volkswagen GTIs and 10 Ford Focuses. We're deep braking. Can't read. When traveling 60 miles per hour on a drive pavement. The results are shown below. Can you conclude that there is a difference in the mean braking distances of the two types of cars? Use a 1% level of significance. Assume the populations are normally distributed and the population's variances are not equal. So first thing we're going to do, HOHA. I'm going to write this stuff out, then we're going to try to use our calculators to find some of the other stuff. Then we'll just look at the answer here. What are we saying this time? What's the claim? They're not equal to each other, right? So is that going to be our HO or HA? So mu1 does not equal, start to pull a weight there and just write an M. Mu1 doesn't equal mu2, and that's our claim. What's our HO then? mu1 equals mu2. Next thing we're going to do, we're going to draw our little graph. Are we left-tailed, right-tailed, or two-tailed this time? Two-tailed. Now, get out your charts, your T chart. We got alpha is 0.01, and we need our degrees of freedom. If the variances are not equal, how do you find your degrees of freedom? What did we just say?
Smaller one.
Take the smaller one minus 1 and find that one, right? Which one's smaller? 8, right? So what's 8 minus 1?
7.
So what's our degrees of freedom?
3.499.
7. All right, now we look on the chart. And for alpha, 0.01, two-tailed, and DF 7. What do we get? What is it? Say it again. 1.895 Wade's saying. Anybody agree with that?
No, I did the wrong one.
Did the wrong one?
Yeah, I did one, not one.
7.
Oh no, we'll probably take another quiz over this stuff next time, so you might want to make sure you're looking this up so you know how to do it.
3.49.
3.499.
Yeah.
What's it goes over here then? Negative 3.499.
Riley, didn't you say that?
Positive 3.499. I tried to get him to say it again, but he wouldn't say it again.
Well, I said it twice already.
You gotta speak up, man.
So we have that. We got our HOHA. We got our little graph. Next thing, and this is where you need to get your calculators out. Get your calculators out and make sure that you know how to punch this in.
Okay.
Go to Stat, Test. We want to go down to, what is it, two sample t-test, 2 sample t-tests. And we want to make sure that we're on stats. Make sure that stats is highlighted, not data. Data is where if you were putting it in a list, all right? So make sure stats is highlighted and it should pop up. And we need to type in these 6 things, right? Is that correct? So you've got those 6 things you're typing in there, your X bar 1, your S1, your N1, X bar 2, S2, and N2. Then I think you have to scroll down a little bit, don't you, because it doesn't show the whole screen? Do you have the answer, Rob? Is that what
Yeah, but I have a question.
What?
Because it's very like specific right there. If we were to round up, it would be in the.
Yeah.
Yes.
Watch that and see.
I don't know if it's supposed to be or not.
So, is everybody with us to that point? You scroll down. Once you have that, you scroll down, and it's going to ask you, what's it ask you next? Does it ask you tailed or pulled?
Yes.
Pulled is next. So is this one pulled or not pulled? Not pulled, so we put no. Then does it ask you the tail?
No, it just says calculate.
Just says calculate after that?
Right above
did
the
ask
pool,
me
it
to
says
scale.
if it's like mu is equal, not equal to, mu is greater than.
So it did ask you which tail, so
Yes.
make sure you put that in. I just don't have my calculator, so I don't remember the order it goes in. And what'd you come up with?
Negative 3.49.
496, so it's not in it.
That's what you came up with?
Yeah.
Yep. See if this is what we got. Let's go through this. And get rid of all that, we know all that already.
Thank God for calculators.
So we had that, again, I forgot to put the claim, which one was the claim?
I do, I didn't claim one.
That one. DF was 7, we used that, found that 3.499, is that what we said the rejection regions were?
Yes.
Yeah. Found it, we're using the formula, is that what you guys told me, negative 3.496?
Yes. We're absolutely.
So what's that tell us? Fail to reject the null, and some of you are right, it's really, really close, isn't it? But it actually falls like right there close, so we still gotta reject it, or fail to reject it, sorry. And then at a 1% level of significance, there's enough evidence to conclude that the mean braking distances of the cars are different. Next one, manufacturer claims that the calling range of its 2.4 GHz cordless telephone, shows how old my slideshows are, I guess, because does anybody even worry about the calling range of a telephone anymore? No. So it used to be, back in the Stone Age,
Bricks?
yeah. No, this is the home phone.
Your can and your.
So, used to be, way back, even before the Stone Age, your phone was actually attached to the wall by this long wire.
We lived through that too.
Not very. So, then they started going to, your home phone would be cordless, and that's what kind of phone this is. So, my first apartment, I couldn't take my home phone and go outside because it didn't have a big enough range to go outside. It would just disconnect if it was that far from the base. You perform a study using 14 randomly selected phones from the manufacturer and 16 randomly selected similar phones from the competitor. The results are shown below at a 5% level of significance. Can you support the manufacturer's claim? Assume the populations are normally distributed and the variances are equal. So this time it is pooled. We're going to just put the two together and figure it all out as one thing. So just a couple of things before I go on. HO. What are we trying to prove here?
We're trying to prove that
mu one is greater than
Are we trying to prove that it's greater than?
well, their claim is that it's bigger than.
we're
So claim is, so HO, HA, which one's gonna be,
HA is the claim.
so this is a claim and it's what?
mu1 is greater than mu2.
Does everybody agree with that? Yes, no, maybe?
Yeah.
And then what's HO gonna be then?
mu1 is less than or equal to.
Yeah, only other thing that we really have to find that I'm gonna go through right now, your DF. Since the variances are equal, what do we do?
Add them and then subtract.
Add up the N1 and the N2, and then subtract 2. 14 plus 16 is 30, 30 minus 2 is 28. So the degrees of freedom is 28. Our alpha is 5%. Get out your charts again. We're gonna be left-tailed, right-tailed, or two-tailed.
It should be it's bigger than right tail.
So it's over here, right-tailed, 0 there, 28 and .05. What numbers that give us on our T chart?
1.701.
1.701. Everybody agree with that? Yeah. Hopefully that's all right. Oops, let's go back. Grab your calculators. Let's find the T by plugging that in. Remember, you go stat, test, 2 sample t-test, type in those 6 numbers. This time, left-tailed, right-tailed, or two-tailed? Right-tailed, type that in there. I could ask you your HA is this or that, whatever. Then pooled or not pooled? They are pooled, so yes. It equals, and then it's gonna tell you what T is. Keep that T around so that we know what it is while I get through all this other stuff here.
Can you read another example?
So we did that,
Well, I'm fine with 2, but 3 examples? There's another one?
1.701, is that right? That's what we said? What did everybody come up with for their T?
1.811.
Okay.
So I did it out all, let me go back so you can see all the work there. That's all the work if you did it without the calculator.
Yeah, that don't look fun.
Notice, even when I did it this way, I'm doing it part at a time. You can't do the whole thing all at once. You gotta do it part at a time, otherwise, I could be wrong, but I don't see anybody getting it right if you're trying to do it all at once. What's that tell us?
That we reject.
Reject. So we reject the null. And then our interpretation at 5% level of significance, there is enough evidence to support the manufacturer's claim that its phone has a greater calling range than its competitor. That's the assignment.
No.
You know why we were here in the gym this morning?
Yeah, we had a meeting.
About what?
whatever they sent an email about, probably.
Throwing a bunch of you out that Ebersole didn't have to put up with anymore.
Yay.
I tried to look at the song, your name was right on the top of the
I'm
list.
sure it was.
Class.
I'm gonna get Jordan to take you over to your house. And deal with you there.
Come over next week, because my family's going on next week.
Oh, yeah?
Yeah, I'll be having a party all week long. They leave tomorrow, and they won't be back till next Saturday or Sunday.
It's probably like a common staff party, yeah.
Well, that was rude. You guys can come over and visit me because I'll be lonely. I'll let you play pool, pinball, darts,
Cool tournament. He's gonna have food and drinks, but you have to summon probably
Football.
food and drinks.
Hey, I'll run it.
I do it.
What else?
I've run
Slop. Big shot.
Dude.
Table
my house so
Why
bad.
could I literally see the house in my nose?
I would
Like,
run.
I just know it's fun.
That's why I want one at my house, just so I can practice.
Get good at
I'll
ping
have to
pong.
scrub that skull.
Force down right.
Dude, I gotta gas.
Whoa.